Okay, what I'm going to do today is talk about earth fields in reference to topographic or topo maps. A field is defined physically as space. Again, you can have, drawing in black, you can have an x-axis, you can have a y-axis, and you can also have a z-axis. X-axis go left and right, y-axis go sort of like this. If you have an x-axis going this way, you have a y-axis going this way, and that would actually give you north, south, east, and west. Same thing here. This is Devil's Tower, which I'll talk about in a second. You can go X, you can go Y into it, or you can even go Z, which is basically the up and down. Two-dimensional pictures don't show that, three-dimensionals do. But anytime you can take the space and time, anytime you can measure those, you've got a field. This is a field, this is a field, that's a field, this is a field. Two-dimensional fields, three-dimensional fields. This is called a, let me go in here and actually, let me get rid of everything I just did. Okay, I add a new layer here so I can delete all this stuff. I drew it on the wrong layer. This is what's called an isotherm. Iso meaning same, therm meaning heat. And what they do is they take all areas that had 65. They just said, okay, this area is 65 degrees, that's 65 degrees, that's 65, 65. 65, 65, 65, and they went through and they just connected all the 65s. How'd they know not to do this one? Because the temperature here was 63, and the temperature over here was 64, and the temperature over here was 62. So they just connected in units of 5, nice round numbers. They just connected all those in there. You can go in and actually take a look at the temperatures here. For some reason, took a dive. Looks like the reds and the oranges, these guys are the, let me pick white up here, these guys are the nice warm temperatures. But you can see this gets yellow into the greens, which gets you into cooler temperatures. In fact, it actually even looks like there's a blue one in there. So for whatever reason, down here in Mexico, they took a dive in temperature, and I'm not sure what was going on down there. I'm located right about here, and you can see we had a nice day. This is actually on Monday, August 13th, 3 days ago. This was at 1600 Zulu, so this was 4 o'clock Zulu. We're -5. This was 11 o'clock in the morning. Okay, this is a drought map. You can actually see droughts, extreme droughts, where we're -2 inches of rain below normal, severe, moderate. So anything you see in these like purples or maroons, reds and yellows, looks like this part of the country, plus or minus a couple of states, looks like this much of the country is experiencing drought of some sort or another. So let's say 80% of the country, this is the 80% that's experiencing some sort of drought. These are iso lines. This is a use of a field. Okay, going back down here, this is Devil's Tower, one of my favorite places in the country. It's in Wyoming. Way back, Theodore Roosevelt actually made this one the first national monument. It's not the national park, but it's a national monument. And what it is, it's an exposed volcanic neck. There used to be a volcano here. But what happened is this all got eroded away. Got lower and lower and lower, and finally until it's all gone. That's the way this thing formed. If you take a look, these are called the Columbar basalts. They're columns of basalts, and this only happens when this stuff forms intrusively or inside the earth. So this is why we think this is an exposed. This is actually intrusive rock in an extrusive expression. The volcano itself would have been extrusive, but the inside of the volcano is still intrusive. Lots of stories on how this thing actually happened. Most of them actually deal with kids trying to get away from a big bear. Indian kids, native kids, actually moved up and tried to get away from a bear by climbing this object. And what these little marks are, this is where the bear's claws dug in, and it looks like the bear really wanted to get those kids because these go all the way around the whole monument. Okay, this is another field. This is called a topographic field, or a topographic map. And this is the same thing, Devil's Tower. Now it's actually on a terrain map, which I wish it wasn't on a terrain map so you can actually see the three-dimensionality. It's actually a way of showing you a three-dimensional Earth on a two-dimensional map. It shows you X and Y, but it also shows you Z, sort of as this thing pops out. These are called topographic lines, and the topographic lines, they come in two different flavors. They're called index contours if they've got a number, and then you can see that they're 1, 2, 3, 4 regular lines, and then there's another index contour. We'll talk about those things. The higher elevations are usually with the smaller circles, and you can sort of see how this thing is going downhill, steeper maybe on one side than another side. You can sort of see valleys where water goes down if and when it ever rains in this part of Montana. It's a relatively dry section. Once again, you take the points that are a different elevation. These right here would be 4330, and there's another 4330, and another 4330, and another 4330, and they just went through and connected these points. And they probably took more readings than I did, and they just connect these points all the way around. What did I do? Okay, there's another 4330, and this is going to be a rule that if you actually cross, that's 43400. So this is 4340, that's 4300, and you can see it just goes all the way around. It goes all the way around. Goes all the way around, and goes all the way around, and eventually comes back to its place. If the map's big enough, it will do that. Okay, there are some laws on a topographic line, and on a topographic map using topographic lines, and I'm going to try to show those to you. I want you to write these down and learn them. All points on a contour line, these are contour lines on the topographic map, represent the exact same elevation as any other point. So I just showed that to you as I traced this line all the way around. Everything on that line was 4340. Everything on this line is 4400. Everything on this line is 4430. 20, excuse me, because it's going by, if you actually take a look at it, it's 1, 2, 3, 4, 5 lines, and it's 100 divided by 5. Each one of these is 20 feet higher or lower than whatever the last line is. So we know this one is 44, probably a darker color. This one right here is 4420. Why don't they write them on every one of the lines? It's not needed. But you do have to figure out what's called a contour interval. Contour interval is equal to the change in elevation between any two consecutive lines. And now we actually know that the contour interval is equal to 20. And they don't really give you any signification whether these are there, and they should in a key, but the map doesn't show the key. This is 20 feet. So every line on here is 20 feet higher or lower than every other line. Law number 2, every contour line must eventually close in on itself to form a irregular circle. Contour lines on the edge of the map may actually jump off, but they have to jump back on. And if they don't show this irregular circle, it's just because the map isn't big enough. Here's a nice regular circle that I showed you that's on there. The smallest one that's there is this 5100, the top of it. You can see it's a irregular circle. You can see lots of irregular circles, but you can also see some that maybe go, let's follow it this way, maybe go off the map, but they have to come back on. That's right next to this one, so there it is right there. Has to come back on the map and it just basically shows that the map isn't big enough to show the whole thing, but it is in a closed circle. With very few exceptions, contour lines never cross. They can't cross because you can't have a line that is this one right here, which was 4340, this one right here, which is 4320, and that one is 4300. You can't have one point have two elevations. Now there are a couple exceptions. An overhanging cliff, and you notice this line right here comes in and it crosses underneath. The lower line's actually showed with a dotted line and goes in, and that means when you climb in here you can actually go underneath this lip of rock into sort of like a very shallow cave. And then I think I'm going to try to show you on this map, and then I'm going to show you a real topo map, one that's sort of like this, but it actually represents a real thing. Moving from one contour line to another always indicates a change in elevation. You either go from this point uphill, which is that way, or that point downhill, which is that way. And it actually is all determined by the contour interval. Contour interval on this map, if you take a look, it's 1, 2, 3, 4, 5 lines in 200. 200 divided by 5. Each one of these things is going to be 40 feet, so that would be 5200. There's 5240, 5280, 5320, 5360, 5400. So contour interval on this map equals 40 feet. Up there it was 20. There's always 4 intermediate contours for every index contour. The intermediate contours are the lighter colored things. Index contours are the darker colored things. And if you take a look at it, we have 1, 2, 3, 4 of those, and you get another index. And you have 1, 2, 3. You don't have 5 of them, so you don't have another index contour. But if we go this way, we have 1, 2. Well, we still don't have another one. If there are more, it seems to show a change in elevation. Let me show you. If we go from this one, this is 5400. If we actually go 1, 2, 3, 4, 5, 6, 7, 8, what we did is we actually went down to this river valley and then went back up. So we can't have, if you've got these lines that are actually the same line as they wrap around, you may get more than 4. So if you count them here, you only got 1, 2, 3, 4, 5, 6, 7. It's not 5, and it's because you're counting this line, and this line, and that line twice. Closer contour lines are together, the steeper the slope. If you take a look at these two lines, if we're changing by 40 feet in this small distance right here versus this distance right there, if we have 1, 2, 3, 4, 5 lines right here in that space, and then we have 1, 2, 3, 4, 5 lines here in that space, we probably have a much steeper slope there. Okay, closed contour lines. The closer the contour lines, we just did that one. A series of closed contour lines represents a hill, like this, like that, and like this. Series of closed, as they get smaller and smaller, represent a hill. Number 8, if the closed contour lines are hatched, like this one right here, it actually represents a point. Instead of going uphill, it represents a point going down. It's a depression. And let me show you on the one that's up here on Devil's Tower. If you take a look at it, the elevation inside is 4293. Now the question is it that line has to be equal to either 4300 or contour interval is 20, 4320, and which one is it? Well, it's always equal to the one that's downhill, because as you go, let me draw it on a side view. As you come up here, there's the 4300, and then what you do is you come up, and then you go back down. There's another contour line. You go back down, you come back up, there's another contour line, which is the same line. Then you go back up here, and you hit this line, and you go back up. And this line right here, actually, let me put it higher because it doesn't show up on the other side. So let me get rid of that. Let me go back in here and draw this. So this would be the 4,300. That's that point. You climb up, and you climbed up, and then you went back down to another 4,300. And then you went back down to 4293, the deepest point there, and then you went back up to another 4300, and then you went back up to a 4320. So it's always equal to the downhill side. This one right here looks like it's a nice dark line, and there is no other dark line around here. But it would be the downhill side. It's equal to the same one as the downhill side. And how do I know that's a downhill side? That's this one right here. Anytime a contour line crosses a stream or a valley, it forms a V shape, like that right there. And that V shape always points uphill. So it points up to that line. So it's the same line as this one. It's not this one. Here's another V which points uphill. This creek is running down this way. It's a dotted line with dashed line with dots. This is an intermediate stream, where this one is a solid blue line, which is probably water there all the time. There's another water there all the time, and it actually is tributaries to this river, which is going to flow off the map and go someplace else. Okay, and that's all I want to show with this one. Thank you much. Bye.